Good evening, everyone. Myself Gautam Sharma. I welcome you all in Sapience Education. So today I am going to solve an NCERT question for thermal properties of the matter. Ten point one: the triple points of the neon and carbon dioxide are 24.57 Kelvin and 201 S. 16.55 Kelvin respectively. Express this temperature in degrees Celsius and Fahrenheit. So let us convert it into, first of all, degree Celsius. So degree Celsius. In case of Celsius scale, so I want to convert it into Celsius scale since it is Kelvin. So we need to see that Celsius is equal to Kelvin minus 273.15. So this is the relation. Now for neon Celsius is equal to Kelvin. Kelvin is how much? 24.57 minus 273.15. So finally when we subtract, so we will get minus 248.58 degrees Celsius. Now for CO2 Celsius in degrees Celsius. So CO2 has a 216 Kelvin. So 216.55 minus 273.15. So we will get minus 56.60 degrees Celsius. Okay, now let us work in a Fahrenheit degrees Fahrenheit scale. So the relationship between Fahrenheit and degree Celsius, so F is equal F minus 32 by 9 is equal to C by 5. So from here we get C 9 by 5, C plus 32. Now let us do for neon. For neon, Fahrenheit is equal to 9 by 5 into degree Celsius is how much? Our for neon for degree Celsius is minus 248.58 plus 32. When we calculate this, so our value will be minus 415.44 degree Fahrenheit. Now if we use the case of a CO2, so let us see the CO2 case. For CO2, it will be equal to 9 by 5 into 56.6 plus 32. This will be minus 69.88 degree Fahrenheit. So I hope you have understood now this. Now let us jump for next question. Now let us read question number 10.2. An absolute scale A and B have a triple points of a water as defined as 200 A, 350 B. What is the relationship between T and TB? So let us consider, when we talk about the absolute, means what? Real. Okay, where it starts from 0. For example, Kelvin scale has a 273.15 Kelvin as a melting point, and 0 Kelvin is a boiling point. So since this is, it starts with the 0, so it's a absolute scale. Kelvin scale is the absolute scale. So let us consider there is another scale A, and there is one more scale B. Now their triple point is this. So triple point means approximately it is nearby a melting point only. So the triple point is this, and the value of triple point is how much? Value of triple point is 200A, and it has 350B. Now we need to find the relationship between these two scale. So let us make a underline. So for this, what happened? For the common heat, so this will come at this range only. So I want the relationship between these three. Let us the temperature at this point is TA and temperature at this point is TB. Now we need to find a ratio between this and this and subtract it between this and this. And when we find the ratio, so you will get the proper relationship. So ratio is TA minus 0, because it starts from 0, it also starts from 0, because both are two absolute scale. So can we write here TA minus 0 by 200 minus 0 is equal to TB minus 0 divided by 350 minus 0. So from here we will get TA by 200 is equal to TB by 350. This got cut. 5 4 ja 20, 5 7 ja 35. So finally TA is equal to 4 by 7 TB. So this is the required relationship. I hope you all have understood this. Now let us discuss for the next question. It is 10.3. The electrical resistance in ohm in a certain thermometer varies with the temperature according to the approximate law. So here they have given the relations that is equal to R is equal to R naught 1 plus alpha T minus T naught. So from here we can see that this is a linear relationship. Linear is the relations. Now they have given some entity. Let us consider a resistance. Resistance at a triple point is of water when temperature is 273.16 Kelvin. So our resistance was 101.6 ohm, and when the resistance is 165.5 ohm, so the temperature is 600.5 Kelvin. What is the temperature when the resistance is 123? So let us consider this is the temperature 123.4. So what will be the temperature? So let us consider this is the temperature T. We need to find the equal ratio. Okay, so ratio of this to this should be equal, right? So let us find the ratio. So ratio is 123 point or we can also start from the here also. We can write T minus 273.16 divided by, so this ratio to the divided by 600, this ratio. that is 600.5 Kelvin minus 273.16. So this will be equal to 123.4 minus 101.6 divided by 165.5 minus 101.6. So when we calculate this, so what we will get? We will get t minus 273.16 divided by 327.34, which is equal to 21.8 divided by 63.9. So finally if we calculate it, so this will be 111.67 plus 273.16. so we will get final result as 384.83 Kelvin. So this is the required temperature at which the resistance is 123.4. I hope you have got the answer, so you have understood the process. Okay, now let us do question number 10.4. Answer the following. The triple point of the water is a standard fixed point in a modern thermometry. Why? What is the wrong in taking melting point and ice and boiling point of the water as a standard fixed point, as was originally done in the Celsius degree Celsius? See, let us consider. Let us see here. There is a scale, or if we are comparing any point, so let us consider a melting point, or we are comparing a boiling point, freezing point, or freezing point. So what actually happens? MP and boiling point both may change with the pressure. Okay, but what actually happen? Melting point and boiling point can change because change in the pressure, whereas steeple point is fixed in any condition. That's why we use triple point because it is universally constant. Okay, so I hope you have understood this question. Now let us see this question. There were two fixed points on the original Celsius scale as mentioned above, were assigned as the 0 degree and 100 degree Celsius respectively. On the absolute scale, one other fixed point is triple point of the water, which is on the Kelvin absolute scale, is assigned as a 273.160. What is the other fixed point? See, one important thing we need to understand, that an absolute scale is a scale whose starting point is 0, or whose one fixed point or other fixed point is absolute 0. For example, if we talk about the Kelvin only, so Kelvin itself start with 0 Kelvin, so this is absolute one. But when we talk about the degree Celsius, so it starts with minus 273.16 K degree Celsius. So this is not absolute. Okay, so I hope you have understood this. Now let us read the question. Question number C. The absolute temperature Kelvin scale T is related to the Tc on the Celsius scale by Tc is equal to T minus 273.15. Why do we have a 273 in this relation and not 273.16? So before that, we need to understand that what actually happens here. See, earlier there was a scale which is made, and that is 0 degree Celsius, 0 degree, it is our 0 degree Celsius and 100 degree Celsius. So this is melting point, boiling point, and this is melting point. And from here only we used to measure the temperature. But after some time, what we have found that there is another temperature, which is the lowest temperature, and for lowest temperature we have got 0 Kelvin. Okay, so in degree Celsius, if we will convert it, so it will be minus 273.15 degrees Celsius. Okay, so it means that this length is minus 273.15 degrees Celsius. But now the thing is that melting point and boiling point often changes. Okay, so there are lots of problem. So there is a need of some fixed point. So that fixed point is defined as a triple point, and its value is 273.15. Luckily it is near by 0 degree Celsius only. So this is the top one. So this length is 273.16 Kelvin. Okay, so the gap between 0 and this one is how much? 0.01 degree Celsius. So that is used 273.15 is already used. 273.15 is used for conversion only. But whenever we want to take a reference point, so we should take this values only. And this 0.01 is the difference between melting point of the water and vessel steeple point of the water. Okay, I hope you have understood this. Now let us do question D for what is the temperature of the triple point of the water on an absolute scale whose unit interval size is equal to the Fahrenheit scale? So what is the unit interval size of the Fahrenheit scale? Let us draw this scale. So this is 0 degree Celsius and this is 100 degree Celsius. But when we talk about the Kelvin scale, so this is 0 Kelvin, but at the same time it is 273.15 Kelvin. Okay, now we need to find temperature such that the interval size of the is equal to Fahrenheit scale. So Fahrenheit scale, so we know that 32 degree Fahrenheit is equal to the 0 degree Celsius, and 212 degree Fahrenheit is there. The gap is 180. Okay, so there is a gap of 100 only. So it means that 1 degree Celsius is equal to 1 degree Celsius gap is equal to 1.5 times the Fahrenheit, right? Okay, now the same gap size we need to maintain. So there it start from 0. So at this point, so let us convert as per them. It starts with 0, and what is the temperature for this? But the size of the scale or the division of the scale should be equal to this only 212 Fahrenheit to 32 Fahrenheit degree. So the size, this type of size we should use. So if you want to use this each size, so let us consider each size contains 1.8 Fahrenheit. So finally we want triple point of the we want 200 273.16 into 1.8, then only we will get this temperature, right? Because it is 273.165 Kelvin is there, but triple point it is 273.16 Kelvin. So when we multiply it, so we will get 491.69 degree Fahrenheit. So this is the temperature which is the required answer for this solution. In question 10.5, two ideal gases thermometer A and B uses oxygen and hydrogen respectively. The following observation are made: temperature, pressure thermometer at A, pressure in thermometer B. So the triple points of the water is given, normal melting point of the sulfur is given. Okay, so what is the absolute temperature of a normal melting point of the sulfur as read by the both the thermometers? So we need to find a absolute temperature. So absolute temperature means we have to take a reference of the Kelvin scale. So let us draw here. This is a Kelvin scale. This is scale A, and this is scale B. Now zero, it is your 0 Kelvin, and triple point, this is, let us consider triple point. So the triple point is 273.15. This is 0A, this is 0B, and triple point for this scale at a triple point for the scale A is how much? It is 1.25 into 10 to the power 5 Pascal. And for this melting point, if we consider it as a melting point, we need to find this. So for this melting point is how much? Normal melting point is, in case of A, it is 1.797 into 10 to the power 5 Pascal. Now we consider for B. So for B it is 0.287 into 10 to the power 5 Pascal, and the triple point is 0.200 into 10 to the power 5. Now we need to compare and we need to find the melting point in Kelvin scale. Okay, so separately we have to take it for A. In case of A, for A, so when we talk about the thermometer A, so what we will do, see, we need to find the ratio should be equal. It is like this ratio to this ratio. Okay, should be equal to this ratio to this ratio. So let us talk about 1.25 into 10 to the power 5 divided by 1.797 into 10 to the power 5. This will be equal to 273.15 minus 0 divided by melting point. So from here melting point will be equal to 273.15 into 1.797 divided by 1.25. So finally when we calculate it, so we are getting 392.69 Kelvin approximately melting point of the A when we compare with the A. Now there is another case for B. or B? So let us consider for B. When we compare it from B, we will get 0.200 into 10 to the power 5 divided by 0.287 into 10 to the power 5 minus 0. Both have a minus 0, so no need to subtract every time. So this will be equal to 273.15 minus 0 divided by melting point minus 0. So from here, melting point will be 273.15 into 0.287 divided by 0.200. So finally, melting point for the case of a thermometer B, we would get 391.98 Kelvin. So one thing you have noticed here, it is 91.9 Kelvin and it is 92.69 Kelvin. Why there is a slight changes? So it is the answer of the question number second. So in the question number second, they are asking, what do you think is the reason behind the slight difference in the answer of the thermometer A and B? The thermometer are not faulty. Since it is not faulty, what do you mean by this? Then there is no incorrectness in the thermometer. So the thermometer used is proper, but the values are varying. Anyone, you can answer it. So first of all, first very important, most important thing is at this case is part B question. Or part B question is that gases are not ideal gases. Gases are not an ideal gas. So if it is not an ideal gas, gases are not an ideal gas. Secondly, it can be rectified can be corrected or rectified when thermometer will be used at high temperature and low pressure. So this is the case where we can get the perfect value, because it will behave as an ideal gas when it is at a high temperature and low pressure. So I hope you have understood this.